In this video, I'm going to show you how to complete exercise 5, showing you how to model the radial engine main assembly, including the sub-assembly that we created in exercise 5, problem B. So here's a schematic of the radial engine. You can see that there is 5 pistons. This is a radial engine, so it's going to fire in a way to where the pistons move in a radial fashion. In the problem statement, we learned that the piston center lines are 72 degrees from each other, so that's an important piece of information that we are going to need to use when setting up our main assembly. And the details for this assembly is shown on the second page, showing an exploded view of the master rod assembly. So, without further ado, let's go into SolidWorks and say File, New, Assembly. And I'm not going to add anything to my assembly just yet. So what I'm going to do is I'm going to click Cancel, and I'm going to show you, we're going to set up some construction geometry before we even start that's going to help us make this assembly. So here's my origin. I have my 3 principal planes. And so what I want to do is I want to take my top plane, and I want that to be the plane that all of my cylinders and rods move about. So I want everything kind of connected to that top plane, moving radially out from the origin. What I'm going to do is I'm going to create an axis between my right plane and my top plane, a vertical axis going up and through the origin. That's going to be my center of rotation for my main connecting rod. So I'm going to go Insert, Reference Geometry, Axis, and I'm going to use 2 planes. And then I'm going to go here, I'm going to click my right plane and my front plane. And click the check. You see now I have axis 1. And so axis 1 is there if I click it, but you notice that it goes away. If you want to see your axis, we can go up to View, Hide Show, and turn on axes, and now that's going to be permanently there that we can see it. One other thing that I'm going to do, now that I have an axis 1 and my right plane, so I'm going to make my right plane be the center of motion or the path of motion for my master rod. So the other rods are going to be opposed from that. So I'm going to go Insert, Reference Geometry, Plane. My first reference is going to be my right plane. My second reference is going to be that axis that I just created. And I don't want it to be perpendicular. I want to select this angle here. I want to type in 72 degrees because that's going to be the angle for my second connecting rod, the path of motion for the cylinder there. So again, let's go to View, Hide Show, and let's turn on planes so that you can kind of see where that plane is that I created. In my right plane, I'm going to show that plane as well. So if you hit this little eyeball right there, so there's 1 plane, 2 plane. Now insert Reference Geometry, Plane. My first reference is going to be this plane. My second reference is going to be the axis, and I'm going to do another 72 degrees. So this plane, which is called plane 2, is 72 degrees from plane 1, which is 72 degrees from my right plane. Insert Reference Geometry, Plane. I'm going to create my next one from plane 2 and my axis, so the same exact procedure. Click the angle, 72 degrees. There is my 4th plane. And the last plane, same procedure again, insert Reference Geometry, Plane from plane 3 and axis 1, 72 degrees, hit the X. So you see I kind of have the star shape going. This is my top plane, my right plane, I should say, that my master cylinder is going to go up and down on. This is my first plane. This is my second plane, third, and then 4th. So I'm setting the geometry up to where I have planes in which I can mate my components to constrain their motion. Now I'm going to insert components, and I'm going to browse, and I'm going to select my master rod. So I'm going to drop that in. That's fine. And I'm going to insert components, and let's browse and select the rod bushing master rod bearings. Let's insert that. Insert components, browse, rod bushing upper. insert components, browse, piston pin. So I'm just dumping all of the parts that are needed for my assembly into my assembly so that I can then just mate them all at once. You could do this one by one, and there's many different ways to model this assembly. I'm just showing you one way in this video. Let's do one piston pin plug. And then let's insert one of the link pin. Okay, so now that we have our pieces there, what I want to do is I told you that my first component is fixed. So I'm going to right click that and say float. So now this piece can move. Underneath my master rod, you notice that there's an axis there. If I go in my feature tree, I can see that axis. So that axis is at the center of my master rod. I can mate that axis to my assembly axis that I created as my first step. And I mate those, and I don't want them to be coincident. I want those to be offset of a distance of 40 millimeters. The reason is because if you look in the problem statement, you learn that the engine stroke is 80 millimeters. So the stroke is defined at the bottom position of the piston to the top position of the piston, which correlates to the diameter of the range of motion of the master rod. So diameter is 80 millimeters divided by 2 is 40 millimeters. Hopefully that makes sense here as we make this mate. So as I look here, this axis is 40 millimeters from this axis. So no matter what, this center line of this master rod is going to spin around that axis that I created as my first step. So 40 millimeters, SolidWorks converts for me. I can click the check. The next thing I want to add for my mates is I want to constrain the motion of this thing to where it's in a planar direction. So I'm going to take the top plane of my master rod and the top plane of my assembly, and I'm going to mate those coincident. So what that does, that allows, see this is kind of moving around, but now I need to add some more constraints. So I'm going to turn off my planes because it's clouding my view here. Okay, so now I'm going to go in and add some mates as we did in our subassembly. So mate those concentric, mate those coincident, concentric. Let's do a advanced mate with mate, blue surfaces, let's do that. And that, purple surfaces, let's do that. And that to get those nice and centered. Okay, so now let's do, the master rod bearing, concentric, coincident. Okay, so everything's good there. Now let's do the piston again from there to there. Okay, and let's do a advanced mate with mate. So blue, let's do here. Drag that out so I can see what I'm doing. To there. Purple, let's do from there to there. That's nice and centered. So now what I want to do, and this is one of the keys to this problem, is I want to remember my right plane is going straight through the part. And I said that I want to constrain the motion of this piston with my right plane. So if I click this piston, under the piston I can select one of the piston planes. So if I look at the piston front plane and the right plane of my assembly and mate those coincident, hopefully you can see what happens here is now when I move, I get the engine motion that I'm looking for, because this piston is constrained because its top plane or front plane, whatever it was, is coincident with the right plane of my assembly. And so it's always going to be there, but my axis is always going to be 40 millimeters offset. So the axis is always going to rotate around the axis of my assembly there. Okay, so now let's take this and we'll mate that surface and that surface. Let's mate those concentric And then let's do from there to coincident. Okay, now remember my copy with mates command. If I right click this component, I can say copy with mates, hit the next, concentric, I can click that surface, coincident, I can click that surface and that piece automatically copies, hit the check. Now let's insert components. Let's grab one of the piston rings. I can then click this diameter and that diameter, mate those concentric. I could drag this up so that I could see, and I'm going to go from there to there, and let's mate those. So in a previous video, I showed you how to do copy with mates. Now what I'm going to show you to do is how to do a linear pattern. If you select these two surfaces and you measure the distance between them, which is looks like 0.2 inches. So I can click this component, say insert component pattern, linear pattern. For the direction, if I click this axis, that would give me a nice direction, and I can say quantity and my 0.2. That's going the wrong direction, so I can flip that around, and I don't need 2, I need 3. And so by using a direction, a distance, and a quantity, I can create a linear pattern for that piston ring. Or you could do copy with mates, it's the same. Okay, so now everything here is good, and I'm ready to insert my subassembly. So I'm going to go insert component, existing part assembly, and I'm going to click select exercise 5B. So I drop that in. So for this assembly, what I can do is I can mate that diameter and this diameter, assembly mate, make those concentric. Now the next thing, so the next thing I could do is I can just select that surface and that surface as being coincident. It looks like there's no clearance between those two. You could also do a with mate to make that work, but there's that. And you look at this, and as this moves, you should notice that the piston is not able to pivot around its piston pin. And the reason is because this subassembly is rigid. And so if I look in my feature tree here, under exercise 5B, if I right click, there's an option here that says make subassembly flexible. If I click that, now when I click this, you can see that that piston has a little bit of pivot around it. That's good, that's what you want. And the last step here is that I want to lock the linear motion of this piston with that, with one of the planes that I created. So so there's my planes, and so I want, and where's my right plane? There's my right plane. So this piston, I want to go with this plane, which is plane 4. So plane 4, and then I click in exercise 5B subassembly, and I find the piston itself, and then I can find in the features here, I can find the plane, that one. So I want to get my front plane of my piston, which is in exercise 5B subassembly, with my plane 4. I mate those two, coincident, I hit the check, and now you see as this one moves, the subassembly moves as it should as well. So now with this piece, let's mate this piece in. This is the link pin. So I put my mate. I want to flip that around, so I hit the mate button right there, flip it around. Let's pull this out a little bit, and then I can click that surface and that surface and get that to be where I want it to be. So for this right now, what I'm going to do is I'm going to copy with mates on my link pin. I could have done this before this step, but I just chose not to. In this example, I want this coincident to repeat, and I want to do the concentric. I just want to go right there, click OK, and right there. So I'm adding in all my link pins. Those are all good. Hit the check. Okay, get out of there. Looks like I added an extra link pin there, so I can just go in and click it, and then press delete. So now we're good. I'm going to select my entire exercise 5B. I'm going to right click and say copy with mates. I hit the next, and basically there is 3 mates that define this subassembly to my main assembly. You got the concentric mate, where I put the bushing down here, concentric with that hole, and then I have a coincident mate, because remember we centered it on that bottom surface, and then the planar mate that located the piston. So what I'm going to do is, for the concentric mate, I'm just going to come over here and select one of these diameters. For the coincident mate, I want that to repeat. Now for the planar mate, what I want to do is find the plane that I want to mate that to. So that would be the next one down. So I believe it's plane 3. Okay, let's hit the check and see what happens. Something looks unhappy, but we'll figure that out later. Actually, okay, let's see what happened. But it's this one. Let's flip this one around and see if that works. There we go. It was one thing was flipped around. Now everything's solved and is happy. So what happened was that mate was flipped around, so it wouldn't work. So now let's test it. Everything's looking good. Okay, let's take this exercise 5B, do it again. Copy with mates. Click the next. So I want to repeat the coincident. So if I go into this, the concentric, let's select right there. The coincident, let's repeat. And now the planar thing, I have to find the correct plane that I created in which would be plane 2 now. There we go. Hit the check. Now the next one is going to be concentric to here. Coincident is repeating, and coincident, now we got to select our, I think this is going to be plane 1. Hit that. And now we've inserted all of our subassemblies. Hit the X. Make sure that it moves as it should, which it does. And now we can see that we have 1, 2, 3, 4 of our subassemblies are input into our main assembly. Everything is here. Let's do a file, save as. Rebuilding is fine. Save this in the exact same folder. We're going to call this, follow the standard naming convention, exercise 5C. Click save. And you're done. Thank you for watching.